Okay, so welcome you all to the next interactive session on network theorem. So this is S.J.Sarkar continuing his discussion on the fundamentals of electrical engineering. And now in today actually we will be discussing with another network theorem that is basically called the Norton's theorem. So in this Norton's theorem, what basically happened that we are having a sort of circuit is there. Now we are converting this arrangement to a much simpler circuit having one current source in parallel to which there will have some resistance connected to it, and then we are having the load connected at the output. So I could say that this is basically the Norton's equivalent of this arrangement, and RL is now connected in the output of it. There is something called ISC. ISC is basically the short circuit current, means the current that is actually going to pass through the branch if the load is short circuited. And Rn, that is analogous to RTH, this is the Norton resistance, and the method of finding this Rn will be same as that of RTH, what we had discussed previously. Now, first we have to find out ISC, then we have to find out IN, and then we have to simplify. And let me suppose I have to find out that what is the power loss. We have to find out the power loss in this particular arrangement. Now, we are having this circuit, we are short circuiting the terminal. So let us suppose this is say node 1, this is suppose node 2, this is suppose node 3, and we are having some node voltages say V1, V2 and V3. If you could think of this circuit very similar to the circuit what we had discussed while having the solution of that Kirchhoff's, the application of the Kirchhoff's law. So the circuit is similar. So we are applying the nodal analysis to find out V1, V2 and V3, and we are actually short circuiting and assuming this node to be at zero potential. Now we are having three nodes, I1, 1, 2 and 3, and now we are going to apply the KCL. So for that we have to consider direction of current. So let me suppose this is say I dash, this is say I double dash, and this is say I triple dash. So these are the currents what we are having. Now based on this we are going to apply the KCL in the three nodes. So for node 1, what we could see, the I1 is coming inside, that ISC will be in this direction and I1 dash will be from this 1 to 2. So for node 1, what we can write? We can write it is I1 plus ISC plus I dash will be equal to 0. There is no outgoing current. And one more point we need to consider now, that this point and this point, they are short circuited. So can we say that V1 should be equal to V3 because they are basically shorted together, so they should be at same potential. Now what is I1? I1 is a constant value. What about ISC? ISC is a variable. And what about I dash? I dash is something like V1 minus V2 by R1, that should be equal to 0. So therefore what we can write is that V1 by R1 minus V2 by R1 plus ISC, that should be equal to minus I1. So this is one equation, so equation number 1. Now we are applying KCL in node 2. So in node 2, what is going to happen? We can write I dash plus I triple dash, that is equal to I double dash. So correspondingly, we are having the relationship V1 minus V2 by R1 plus V minus V2 by R2 equal to V2 minus V3, that would be basically V1 by R3. So if we are going to simplify it and rearrange, what we are finally going to get? We are going to get something like this one. V1 1 by R1 plus 1 by R2, 1 by R1 plus 1 by R3 minus V2 1 by R1 plus 1 by R2 plus 1 by R3 equal to minus V by R2. So this should be equation number 2 that we are getting. Now for node 3, what is going to happen? We are having I double dash plus ISC should be equal to I2. So putting the values, I double dash is V2 minus V1 by R3 plus ISC equal to I2. So what we can write? Minus V1 by R3 plus V2 by R3 plus ISC should be equal to I2. So let us suppose this is equation number 3. So we are having 3 equations, 1, 2 and 3. We are having 3 variables, V1, V2 and ISC. So solving that, we could find out what is the value of ISC. We can find it out by solving these 3 equations. So we have found ISC. Now next we have to find out Rn. So for finding out Rn, what we need to do? We need to deactivate all the sources and replacing them with their internal resistances. So for the current source, it will remain open circuited. And what about the voltage source? For voltage source, it will be short circuited. So it will be short circuited. The current source will be open circuited. So what is going to happen there? Now we are going to check what about the resistance. So if you could think of carefully, practically no current would be passing in this loop or in this loop. So we could say that this Rn is basically equal to R1 plus R3, that is equal to RTH. We would be having the current flow in this direction only, and therefore this should be the equivalent resistance. So that would be the value of RTH. Now we are forming the Norton's equivalent arrangement of this particular circuit by doing all the calculations. So what would be the current that would be passing through RL? Let it be IL. So IL will be basically what? It would be Rn by Rn plus RL into ISC. That is what we are going to get. Now once we are getting IL, so we could find out PL, that would be IL square into RL. So this is what is actually being desired, and by what we have done, we are having this arrangement. We are simplifying it by using the Norton's theorem. Then once from the Norton's theorem, we are having the simplified circuit. So for the value of RL, we are finding out what is the power loss. So this is the way basically by which we are going to apply the Norton's theorem to simplify any circuit. So hopefully this discussion would be having some benefit. If still you have some doubt, you can ask me without any hesitation. So I'm stopping here. Thank you. Have a nice day.